So in this episode, we take a look at the neuroscience and the brain structure of reptiles. Welcome back to the Animals at Home podcast. My name is Dylan Perrin, and this is the podcast that explores the ethical captive management of reptiles and amphibians through the lens of biological science, human nature, and conservation. Joining me on the podcast today is Daniel Yates. He has the YouTube channel Learning for My Reptiles. And in this episode, he runs through a PowerPoint project that he's given to a couple of different herp societies, all about the neuroscience and brain structure of reptiles. In the episode, Daniel breaks down the structures of the brain as well as what each of those structures' function is. We also look at a wide variety of species and how those structures actually change based off of the animal's mobility or how they live, the environment they live in. Daniel also gives us quite a few of his own personal hypotheses throughout the episode, specifically discussing how reptiles interpret and interact with reality based off of the brain structures that they have. Now, as of right now, Daniel doesn't have necessarily enough data to prove any of these hypotheses one way or the other. He's just at the early phase of this, but we discuss his ideas on memory, modeling, empathy, and the list continues to go on. There's a lot of information in this episode, and if you're somebody that's listening to it, I highly recommend watching the episode instead of listening, whether that's on Spotify or YouTube, because he does walk us through his PowerPoint, which has quite a lot of information in it that will make it a lot easier to follow along if you're visualizing it with us as well. I hope you enjoyed the episode. Make sure you let us know in the comments what you think, and if you'd like us to dig down into this topic further, we can absolutely do that. Enjoy the episode. This episode is sponsored by ZooMed and their Repti Habitat Pro 120, which is a 2x2 by 4 foot PVC enclosure that comes with locking glass doors and a beautiful metal mesh top, which allows you to have the appropriate lighting for whichever animal you choose to keep in this enclosure. It ships flat packed, which is very efficient cost-wise rather than shipping these large bulky enclosures. And it's really a perfect enclosure for everything from a bearded dragon to a ball python, or maybe you want to keep a group of smaller species in there as well. I will tell you more about this beautiful enclosure by ZooMed later on in this episode. If you are running bioactive setups, then you know your cleanup crew is not optional. It is absolutely essential. Isopods and springtails break down waste, recycle nutrients, and keep your system from crashing. Later on in this episode, I'm going to tell you all about the cleanup crew kits from the BioDude. These kits allow you to culture your own isopods and springtails at home, or you can buy a species-specific kit that is already catered to the specific reptile or amphibian that you're keeping at home. Or if you're somebody who actually loves the look of an isopod, you can buy their premium display kit and display your isopods for everybody to see in your reptile room. Stick around for later on in the episode to learn more about the cleanup crew kits from the BioDude. Awesome. Well, Daniel, welcome to the podcast. I'm really looking forward to this, and it's great to have you here. So thank you for being here.
Oh, I'm super excited. I've told I know you guys talk about, like, you don't talk about it at work. I do. I've been told I need to stop talking about it several times, but I bust my butt so much and I make sure everybody else's job and I take care of everybody else so much. And they see the passion that they're like, no, we're good. We're like, they don't make fun of me and stuff. And honestly, half the time, if you're really passionate and people really care, they may not care about your passion, but they care that you have a passion.
So true.
It really is interesting, because it's like, I know I'm boring them, but some of them, they are just like, oh, dude, this is flabbergasting, like, awesome. Like, what are you talking about? This is so interesting. So yeah, and I mean, if you got somebody doing that's like, I don't like this, you need to stop. Something wrong with them. If you're truly passionate, there's some insecurities there that they're just like, no. And that's something that I really want people to take away from this, is that you don't always have to be the smartest in the room or whatnot, but if you bring something to the table, just because somebody else wants to put you down doesn't mean you shouldn't just go through with it.
Mm-hmm. Yeah, that's a fantastic point. And I feel like that's a great way to kind of start this conversation, because the stuff that you're doing, I think, is very, I think we could say far out there and trailblazing, really. You're doing a lot of this kind of on your own, and you're kind of putting these pieces together. So you kind of have to be that guy.
Yeah, welcome to the weird side of herpetology.
Yeah.
In a room full of weird people, I am the weird outsider.
Yeah. So it's like a couple standard deviations from like the general public then, which is okay.
Yeah. Oh yeah.
Well, I think
So
I want to get into like we'll get into your history and all that later. Like we'll talk about how you got into keeping and maybe your education and whatnot. But do you want to just jump into the presentation you're working on, just so we can get into
yes,
that, and then
yeah,
we'll get into all the nuts and bolts of that.
yeah. I'm learning for my reptiles, and the full title for it is learning science and how to deal with people for my reptiles.
Mm.
That was the whole point of the channel when I started it. Um, and I am a scientist. I have worked in multiple laboratories and stuff, so this is interesting stuff.
Yeah,
All right.
we're looking forward to it. So if you are listening to the podcast, Daniel is sharing his screen. He's going to walk us through a PowerPoint presentation. So if you're watching on YouTube or Spotify, you'll be able to see everything. If you're just listening, follow along as best you can, but you may have to double back to one of the video versions just to kind of get some of these visuals. But we'll try to do our best to kind of keep it audio friendly, but most people watch the video anyway, so it's not a huge deal.
And that's what that's what I wanted to say earlier.
Mm.
You're going to have my PowerPoint on your links, right?
Yes, I can provide
So people
exactly.
can follow along at home and actually pull up the PowerPoint
Yeah,
itself.
we can do that. Absolutely.
Yeah, that's cool. I like that idea because that's way you guys get a more like detail in your face look. But I started giving this talk last year and understanding the neuroscience of reptiles to help understand the brains of vertebrates. Vertebrates. And so this is a bearded dragon brain. And so we see the different colors. So we'll start out with the light blue here at the top. This is the the OL factory stock, the oral factory stock. This is where, and this is a bearded dragon brain. Like this is a MRI from a bearded dragon brain, deal. And so this part out front, if you guys can see, should I like have a marker a little bit or something? I don't know.
No, I think it's good. I think we can see your mouse pretty clearly.
Okay. I just want to make sure. So yeah, so this is the lobe, and this deals with their smell, their taste, things like that. The red part here is I'm going to butcher this word. So I call this the forebrain. But most likely, if you're actually talking to a lot of people when it comes to forebrain, they're probably talking about both pieces because the OL stock comes right off of the, I call it the forebrain because it's so much easier to pronounce than like
telencephalon or something.
Yeah, like it's, I'm not a biologist. I'm a scientist. I don't name stuff for a living. I'm sorry. Yeah. And so then we have the orange here. That's the thalamus. That is what connects everything together. And so your pink here is the optic nerve. So like we have it behind our eyes, they have it underneath their brain. And that thalamus connects those two, and the green, the dark green, is the optic tectum. It's where your sensory input like sight and sound are dissected in the brain. So this is a very important piece. And so then you have the yellow is the medulla, which is your spinal cord connection. It sends the signal down. It deals with a lot of other things that I have not researched as highly as I want to right now because I've been so busy with the baby savannas and a lot of the other stuff I've got working on right now. So I haven't had time to go over the book as much for that research. The neon green is the cerebellum. So that deals with your motor controls. So if I throw you a ball and you don't catch it right away, and yet I throw you a ball again and you catch it, that's what's happened is your cerebellum kicked in. And this is actually every piece of this brain is in here. Every piece of that brain is in this brain.
Every piece of a bearded dragon brain anatomy is in the human brain. Yeah.
Yes. So that's something to always remember. And that red part, the forebrain, that deals with memory, imagination, deals with your central nervous systems, your decision making, and that'll be very interesting. So I need to go more into evolutionary. I focus more on the functionality, and I'll explain later why I go over functionality over evolution right now. But this, if we go back in history, this is supposed to be the great ancestor for all vertebrates. All vertebrates. Doesn't this look like a langolier?
It's kind of a weird like barnacle looking thing.
Yeah, this is our great ancestor. We have the same ancestor as that snake behind you. Yeah,
that is wild to see.
We're all there. And so the human brain we actually see as a sphere. So this is very spherical, while the reptile brain is linear. So to explain the reptile brain, you have three humps, is always how I describe it. First hump is the forebrain, the decision-making stuff. The second hump is their instinctual brain, the sight, what dissects their sight. And then you have the third hump is the cerebellum, which is the,
motor control.
Yeah. So what we see here is whales have a spherical brain and sharks actually have a linear brain like reptiles do. And so what happened to the human brain is that first hump overgrew the second hump. So their brains are not just linear, they are, how do I say that? It's an easy word. Lean. Their brains are lean. Where that forebrain in us was so massive, it overtook the second hump.
So is it almost that the forebrain in the human brain like engulfed the midbrain almost?
Yes. Yes, that's exactly what happened. And so when you look at a human brain, what's interesting is it's spherical. So therefore, if you think about the shocker where you put your fingers on it and it just lightnings out, that is what a human brain does when you think of actually how it communicates with itself. All those signals can go everywhere at once. Whereas a reptile brain, a linear brain, can't just do that. It actually has to travel. And so what we see is, when you look at the linear brain stuff, they are very single-minded. When you look at sharks, how many shark attacks? What's the difference between a shark attack and when your reptile bites you? Just because you had the bug in your hand.
Yeah.
There's nothing. There's no difference.
Instinct, yeah.
Yeah. I hate that word instinct. I hate it because it lets us off the hook. And we'll get into that because I still use the word instinct because it kind of helps to put something in perspective, but it kind of lets people off the hook to not learn what's actually happening in their brain. Well, we know what's going on. It's just instincts. Like, no, hold on a second. What's really happening? And so we'll talk about that. So here's a frog study. And so this frog study was they dissected a bunch of different frogs. And I went in and took every single word out of that study. Everything that they saw in that study. This is a frogs, multiple types of frogs. And so I compared it. So I look everything up. Is there a human model of this? Every piece of this has a human model. Like I said before, we have everything that they have.
So you mean that every structure in a frog brain, there's an analogous structure in a human brain?
Yes. It's
Gotcha.
Not one-to-one by any stretch of the imagination, but it is similar.
Gotcha.
And that's something to Absolutely. And this is frogs. This isn't even a reptile. So I like to teach this. This is blind sight. So blind sight is when your eyes work and your cerebral cortex does not. So what we actually see, and we most of us know that your right brain controls the left side of your body and your left side controls the right side of your body. Mm-hmm. Everything goes crosswise. So what this is showing us, because I mean, most people like just automatically think the way we were taught in school. And that goes back to, teaching beginner stuff. Like it's interesting. Should we have been taught this like this, or should we have had a more? I find it an interesting question because it travels. And because your cerebral cortex takes up so much of the actual power in your brain, when they MRI and that works, that's all you really see because it's so powerful. So what they actually got to do with this is actually see that the eyes work, but that is quiet. Mm. So they were able to actually see the pathway that the eyes actually took the information. And right there in the middle, that little spot inside the human brain is modeling. And now we know why it touches modeling. And it literally travels like lightning, like those lightning balls through the brain, but yet it has actual corridors it wants to take. There's a lot of questionable things here, but I think I remember, and memory is not always the best, but I think there's like 12 spots that stuff drops off into your brain long before it gets to the cerebral cortex. So you're taking in so much more information before you even see it. Mm-hmm. Before that cerebral cortex goes, hey, this is what we're looking at.
Well, I think people could have this. You could have this experience where you are looking for something. Let's say it's on your desk, and somehow you instinctively know it's there, but you can't see it. It's like, I know this thing's here. I just, for some reason, my eyes aren't locking it in. When I have those experiences, I just assume that my eyes have picked up on it, but it hasn't made it all the way to like my conscious side where I can like actually connect the dots.
And actually, what they actually did was, in these studies with blind sight, they would stick a color or a shape right here, and they would actually guess it more than they could ever have done randomly. Mm-hmm. Like they actually almost got them all right. And then like if somebody smiled, they would smile.
Right. So they physically can't see, like they're not actually able to visualize what's happening in front of their eyes, but their eyes are still detecting what's happening and it's still communicating that to the brain. It's just not making the last step to have the visual piece enter the brain.
Yes, exactly. Yeah. And there's a point to this. I love teaching this because there's a point. So if we actually start understanding that these things don't just magically appear in the back of your head, they actually have pathways that they take. So if we start like, so if the animal is feeling something, that's going to go to its medulla. It's going to move up and it's going to make some feedback loops into the cerebellum. And then it's going to go out the tectum, optic tectum, and then to the medulla or the thalamus, the thalamus. And then that's going to travel it to the forebrain for them to make a decision. Mm-hmm. And this is where I think a lot of people have been very interested. So when we look at that optic nerve that sits underneath, so now sight comes in there, it goes to the thalamus, and it has to go to that second hump to be dissected, to actually get filtered the way it's supposed to be. And then it has to travel back out and actually go to the forebrain, the first hump. This is incomplete. What I'm saying is incomplete. So anybody at home going, well, you understand, I am trying to teach this on a base level to give us an understanding of our animals. So if they actually, like I told you before, instinctually comes out of the optic tectum. Hmm. So that optic nerve sends that signal to that thalamus, goes to the optic tectum. And if they sense something bad, what should happen?
I guess
What would be what?
they'll react in some way, right? There'll be some.
Yeah. So it'll move down the medulla, and it'll activate a couple of different spots and move the body instantaneously, or feels instantaneous.
Yeah.
So when they make a decision, what should happen? It goes from the optic nerve to the thalamus to the optic tectum, back out of the optic tectum to the forebrain. They have to dissect it and then make a decision. And then that has to actually go back to the optic tectum and back down to the medulla to move the body.
Interesting.
So you should see a delay.
Now, what about like a fight or flight situation? Would it also, like, because there's less of a decision feeling when there's a flight or fight situation, right? Your body just sort of reacts. Does it still go through that kind of process?
Remind me when we get to the forebrain or optic tectum.
Sure, I will.
Because that's a little bit more advanced, but yet it is something that's important that we could actually still discuss.
Okay. Yeah, sounds good.
So this is Calm Fancy is in that 40 gallon. I was living in a little apartment trying to move. Hydra is down there at the bottom. Calm Fancy sees Hydra. He's not black bearded yet. And if we actually look, it took him over 30 seconds. See, we go from 0 to around 30 seconds. He's head bobbing.
Mm-hmm.
He started head bobbing about 30 seconds in. And now his beard's black about a minute in. So what does that tell you about black bearding?
There's a little bit of a delay to the visual response.
So, yes. So if there's a delay response, you know what's happening? It's a decision. So it went to the optic tectum, got dissected, went to his forebrain, and he made a decision. And that decision then shifted down. And it could be interesting to note, like, the amount of time it takes for that beard to actually turn black with the actual hormones and stuff. I don't know what that is, but the head bob and stuff, it took a second. It wasn't just instantaneous. And then it also takes him a while to calm down from it. It's not instantaneous like people think. Okay. Okay, so the other part of this. So that's if the decision isn't a learned behavior. So I had a couple of emerald green tree skinks when I moved from Kansas City to St. Louis. We can see the time here, the timestamp. I caught this skink while I was at work and I recorded him. And I sped up the footage, of course. He's in play. So he's actually climbing to the top of this majestic palm and jumping down. But watch him stop. And that stop takes less time every time he does it. Because he's learning. And he actually, I don't know if it's, I think I'm wrong on that one. Let me rephrase that. Memory is a fickle thing. And that's why I don't get on to people from memory. What's happening is his stops are about the same amount of time. His time in play lengthens every time. That's what's happening. So he's actually planning stuff out. He's making decisions, but get faster, and he doesn't need to take as long every time because learned behavior changes that. So if it's an unlearned behavior, you should see a delay. If it is a learned behavior, it's kind of up in the air. There's still more studies I think need to be done on that. But if it feels instantaneous, it's probably instinctual. So they're just using that optic tectum, not the other two.
Mm. And so how would you, like, what makes you say that he's playing in that situation? Because I do think play in reptiles is something that's very interesting and something that's probably in the next maybe decade or so will become more obvious. As mammals, I think we have a hard time distinguishing when an animal is playing when it's not a mammal. Like, it's very easy to see when a dog is playing, for example. But with reptiles, it's not. But I've seen studies on turtles playing and these sort of things. And so I'm curious about just when you're watching that animal, what makes you think that he's in a playing mode and not something else?
Well, there's two things that I would say that he could be doing, and play is one of them. He's making that decision, but he also knows that's the exit. So he could be trying to jump out of the exit, but that doesn't also mean that he's not in play. And as we know as kids, we know that play helps us map things.
Yes, of course.
And they absolutely map their territory. So to them, that could be a play. So he's brand new to that enclosure. That was quarantine. So and even if he's trying to get out, that doesn't mean that's not mentally stimulating and play. But yet you could make the argument either way. But I would say that's play no matter what, because it is activating the brain, mapping things. It is exciting for him. Even if it's stressful, it's still mentally stimulating.
Yes. Yeah, that's so true. And I imagine that, I don't know if this is a true statement, but I'm sure it probably is close to being true, is that territory mapping probably rarely happens when an animal or a person is in complete fear. You know, like if you are at a high level of fight or flight, like you're not necessarily mapping territory.
That's a super interesting question, and I do not have an answer. But I have never thought about it. But I mean, your senses are so heightened during fear.
That's true.
Oh man, actually, I just watched an episode while I was at work this week or last week, where they were talking about, they found a drug for and they're doing studies on fear, and it's a heart medicine. Well, every time you look at a memory, we're talking about how bad memories are. Well, every time you look at a memory, it changes. And I didn't realize why. They said it resaves. That's why it changes, because it resaves.
Interesting.
Every time. And what that heart medicine does, what it can do, and it's been out for heart medicine for years, so it's FDA approved. But what it could do is stop the hormones from happening to where you do not resave memories.
Wow. So what does that mean? Does that mean you retain the original memory, or do you start forgetting things?
I don't know.
Interesting.
I thought it was fascinating. I think it's a very, very interesting thing. And so I don't know. I'm going to tell you, I have no idea, but I would love to get into it. But right now I'm focused on so many other things.
Yeah.
But yeah,
that's cool.
And to work, yeah, I do so many mundane tasks that I really, like focus. I have to move this, I think, because I don't know if the audience is actually getting the full scope of this thing.
I think we see the full slide.
Oh, can you see the full slide? I don't know if you can or can't. So at the bottom, this is a study. So all the 4D models that you'll see in this thing are from this study. It's from this lab, this Pa lab, Nicholas Di. I know I'm probably butchering that. And so this study right here, they had like 40 different reptiles in it, and they actually 4D modeled a bunch of them. And so that's what I use in a bunch of my studies and stuff is to actually show through those 4D models. So you'll see this is an actual study that was done. And they said out of those 40 species, there was only one thing that they could find that actually had the correct p-value. P-value for people at home. I'm sure your audience is like your audience comes here and they're probably very intelligent. So I think they will get this, but the p-value is a statistical analysis that they used an equation. And at a certain point, you have to have like a 0.5 or a 0.01, depending on what kind of sciences you're doing and stuff, to actually get a proper value that shows that there is a correlation. And so that p value, the only correlation they could make over the 40 species is the cerebellum, the third hump. So if you're talking about limbless and legless actual creatures, they're so if you have the three humps here, as you look on the side here, the bearded dragon brain, that cerebellum is actually headed over the actual optic tectum for a bearded dragon. And you'll see that in all quadra, so reptiles with four arms. So what I keep, not snakes, but the pre-evolution of snakes, and so you'll actually see that hover over it, whereas snakes and limbless moves often away from the actual optic tectum. So it actually leans away, whereas if it's a quadruplet, it'll lean towards it. But you can see the thickness of them. And the more terrestrial it is, the more thicker it is. Multi-habitats, whereas arboreal, you'll actually see in the quadruplet. But yet the other one, it's different. So snakes' motor function is different than a lizard's motor function with dealing with this. Like I said, this is the only thing they do this. So this is also the part of the brain that Parkinson's kind of hesitates. Like, this is what it affects. So when your bearded dragon flips over on its back, this is basically one of the parts of the brain that's mainly dealt with that. And Parkinson's is just like Alzheimer's, is a loss of cells. And so this happens with old age. It happens with actual disease. But this is the part that'll do that. So when your reptile flips over, this is what's being affected.
Right. So this is sort of just showing, like, it's interesting, the size of the cerebellum increases or decreases based off how much different type of movement or locomotion that these animals participate in. If you're somebody that's just a burrower, you have a relatively small cerebellum compared to something that's more multi-habitat, which is going to have to move in a larger variety of ways. That change actually increases the size of that part of the brain, which controls motor movement, which sort of makes sense. Today's episode is sponsored by Zoomed and their Repti Habitat Pro 120, which is a 2x2x4 PVC enclosure that comes with locking glass doors and a metal mesh top. This enclosure is roughly 120 gallons, which really does give you a ton of space to work with, whether you're working with a corn snake, a bearded dragon, a ball python, or I think you could even do a small colony of lizards like long-tailed grass lizards, or even a group of anoles would look amazing in an enclosure like this. 120 gallons gives you a ton of space to build out all the habitat as well as the enrichment needs that your animal absolutely requires to thrive. The Repti Habitat Pro 120 is PVC with lockable side latches on the doors, as well as side vents, which will allow for cross ventilation, which is crucial for allowing for proper airflow. And you also have an adjustable cord port, so you don't have to drill holes into the enclosure for whether you're trying to get a probe in there or misters or heat cables. The top of the enclosure is a heavy-duty metal mesh, which is perfect for allowing proper lighting. Huge on providing UVB, proper infrared, and visible light, and a mesh screen allows you to do that without any issues. And one of the most practical elements of this enclosure is it does ship flat packed, which is going to save you a ton on shipping. So whether you're looking to upgrade out of the starter enclosure you currently have your animal in, or maybe you're looking for a new animal entirely, I absolutely recommend checking out Zoomed's Repti Habitat Pro 120 for all of your enclosure needs. For more information on this or any other Zoomed product, make sure you head to zoomed.com or check out the link in the show notes or the YouTube description.
Yeah. So the medulla. This is a ball python and rainbow boa. This is where I got my start in this thing. I love this. So as we look at the cerebellum here, we see that the rainbow boa comes right down, like the cerebellum pushed down on the medulla and goes out the back. Whereas this ball python we see that the cerebellum didn't actually push it down all the way. It actually travels further south than the actual cerebellum pushes it. So this is saying that the medulla is longer percentile wise than the actual rainbow boa per brain.
Mm.
So the skull has nowhere to go with it. So it's actually dipping down below the cerebellum. And that's really cool, really fascinating thing. So we're talking about this yellow part over here.
Right.
On the bearded dragon. And so as we look at the flying dragon, we see the cerebellum or the medulla drops below the cerebellum. Whereas we see the flying snake, the cerebellum is what's pushing the medulla down. It's not the medulla traveling below it, which is really interesting. So what's happening is that we know that the ball python buries itself compared to a rainbow boa.
Mm-hmm.
So it has more tactile sensation happening than a rainbow boa. And we have the flying dragon has stretched its actual rib cage, its rib meat. Whereas the flying snake is just loose skin. It does not stretch its skin. So, yeah, the tactile nature. So I like to say it's an over tactile sensation. So if their tactile sensation is being overclocked, the medulla grows. There's nowhere for it to grow, so it actually kinks below further than the cerebellum. So it takes up a bigger percentage of the brain than it should. Well, and then we have the hognose study that, everybody was controversial a little while back. And it was really well done. Remember I said that study? That guy's out of France, that study that I use these 4D models from.
Right.
He's actually made a lab out there. It's really cool. I haven't been able to contact him or anything, but I actually found it fascinating. He's an academic and everything. So their study says they didn't find anything besides the cerebellum. Whereas this guy, so when we're talking hindbrain is the cerebellum and medulla. The midbrain is the optic tectum and the thalamus, maybe. Whereas the forebrain is the OL stalk and the forebrain, what I call the forebrain. So they said in the study that they were able to find an increase by 10% by adding things that they can touch and see to the midbrain and the hindbrain. So the medulla, the cerebellum, and the optic tectum actually grew. And they were able to find a correlation. I did that other study. I apologize. Can you hear me better still?
I can still hear you. Yeah.
It did something like I apologize.
No. I think it's all good.
It switched to my my earphones instead of my microphone.
Oh, I think it's still coming through your mic. Can you tap your microphone for a second? Oh no, maybe it's not. You still sound fine.
Okay. I don't know how to audio.
Yeah, there's a little arrow by audio. It should give you an option.
Okay, standard speaker microphone. The Yeti.
Yeah,
did you hear that? Okay, so it switched it back.
Yeah. Okay, good.
So the reason why they were individualized, all these hognose snakes were treated from day one. So we actually know now from this study that these things grow individually. It's not just one species, one shape, one size. They actually grow accordingly to what's actually being presented.
Hmm.
Where that other study, they probably used wild caught and just stuff that was in the hobby. They had a three-toed gecko, but and a fire skink, but not a blue tongue skink. Like it, so they're using wild caught stuff. So there's no telling what that experience of that animal was. That may have changed the brain size and stuff. So that's why they probably didn't find correlations that they wanted to.
So what did that study inevitably show? Like the wild caught one, or what you were kind of assuming is wild caught?
I don't think they really concluded whether they were wild caught or not. They were just taking brains
Sure.
and looking at local motor functioning and trying to compare to see which one survived the p-value.
Gotcha.
And they were just using sizes. So this really shows us that they're individualized brains.
Hmm.
Because it was those 15 and half of them were treated with nothing in their enclosure, nothing in the tote. The other one had chips and they had sights and they had other things going on. So it really shows you that it does affect individuality.
Right. So the animals that were exposed to more legitimately had larger brains by the end of the study.
Yeah. And that was the hognose study. That wasn't
study,
that wasn't the 40 species. The reason why the 40 species didn't come up with anything else is probably because of individuality. That answers that question, why this study found things that the other one didn't.
Right.
Yeah. It's really an interesting thing.
Yeah, it really is.
And so I like to show this. This is cool. So if A and B. So one of these is a flying squirrel brain and the other one is a gray squirrel brain. Off of the medulla talk that we just had, which one's the flying squirrel? Because the flying squirrel stretches its skin.
If I would assume the one on the right with the larger medulla.
The medulla is over here, the spinal cord stuff.
Oh, that's okay. I'm looking at it backwards then. So
are you looking at it backwards? Okay,
I think I'm just yeah. Okay, that's the spinal cord. Yeah, gotcha. So that would be so that one's the larger medulla. So that would be the animal that does the flying. Yeah.
Yeah, the flying squirrel over here. Yeah, exactly. So this is telling us that this is a vertebrate thing, not a reptile thing, a vertebrate thing.
Yeah,
which is really cool. I talked to a professor once and we were talking about this and she goes, yeah, you need to compare that to other vertebrates. I go, I did. And it's really hard to find vertebrates that really have this and you really have this brain model.
Right.
So the flying squirrel was great. Like this was great to find.
Yeah, that's really cool.
Yeah. So the optic tectum. So like we talked about instinctual stuff. And so we know the way it travels. So we go back to the blind sight and we know it travels. We know information. If basically think of it this way, is if the sensory touches it, it affects it. So if it's movement and it goes down your medulla and it touches the cerebellum, it probably has some effect on it before it actually gets to the optic tectum, and it could do it simultaneously. So, and like we said, instinctual. So in the human brain, this is where we get into controversy. And I want people to understand, I'm not saying this is 1-to-1, but this is right. And so at work, I try to do things. Let me back up a little bit. Laura Trini asked an interesting question once. Well, she's asked quite a few, but she asked the question, do these things see us as a whole or individual parts? Okay. So when I go to work, there's bunnies in my parking lot at work. And also how I handle lizards, which we'll try to get into later. I don't look at the bunny. I've done this study where I've actually looked at the bunny and he ran off faster. than if I don't look at him. Think about how many people hike, like, or the herpers. I hear it all the time on, like, Klubrid and Klubrid and things like that, where they're talking about they basically almost snipped on the snake and it never made a sound.
Right.
Because they're watching your eyes. They know what you're looking at. So their brains can be that detailed. But think of how quickly they move. What did we talk about earlier? The quicker, the more it feels instantaneous, the more likely it is to be out of the optic tectum. So in the human brain, we have the eyes here, and they'll send that signal. And about right here, you actually have a piece on this side of the brain, on this side, your right side. It's a little quarter size. It's modeling. It is part of empathy. So when you smile, if I yawn and you yawn, that's the part of the brain that's being activated. That signal has not gone back to your cerebral cortex and then that's it. No, it actually got there before your cerebral cortex, and it's just automatically. Even the blind sight people did it. And so we see that. And so what are we saying here are that these animals have a version of empathy. They have that modeling. So there's 3 parts to empathy when you talk about humans. Back here, so your memory retrieval is in this side, your imagination is in this side. Imagination, memory retrieval. Your memories are stored all over. So when we're talking about empathy, you have that part inside, and then you have this right here, that's about right here, about right behind your ear to the top, is the putting yourself in other people's shoes. So empathy is actually a part of your imagination, which makes sense because you can't live somebody else's life.
Right.
The third part is your frontal lobe, which is something we will absolutely not get into in this video. But think about the way their brains are designed. They're linear, where ours is spherical. So somebody that grows up actually makes that connection, can become an empath between those 2 spots. That's what happened to me. They would struggle because imagination is in the red part of the brain, where the green part is where they would have that modeling. And there's studies that talks and stuff that I want to do. I want to get with Happy Bazin and Brassman. I've tried to have them on. I've talked to them, and we were supposed to schedule something. And there's more here. There's so much more here to understand. But they have that modeling. So when you hear Green Root Python talk about his snakes headed in the same direction together, and they actually hide together, or Research in Reptiles talked about the study that they've done with ball pythons where they all use the same hide. This is why. That modeling is coming straight through the optic tectum. They're modeling. They're using a part of empathy. Now, is it 1-to-1? No. And there is so many more questions than answers that I have right now. So we'll move on from this. But they do absolutely 100% have some version of modeling.
Interesting.
What exactly it does is still up for questions. And this is where we get controversial because people, well, they don't have empathy. They don't. No, they do. The way you look at it, like we can understand why they wouldn't have empathy the way we do, because they don't have that connection so closely together, that spherical brain. So the tokay gecko is a big one to take in here. So as we look on the left side of the screen, or you're right, I guess, the brain model, this is not a tokay gecko model. Out of that study of 40 species, this is the model that they use to teach you how to read their models. So you know what these numbers at the bottom of the screen mean, the landmarks. So I circled the landmarks that I have at the bottom of the screen. So it is the optic tectum. And so we're talking about the tokay gecko. And so if you look at the bottom, tokay gecko is the first one. Uh, it is the day gecko is the second, going from north to south. The bearded dragon is the third, and ball pythons are the last. And if you look at all the whites, all the clear ones, it looks really, really similar. Like they have a ratio to them that's actually reasonable between the two. What's really interesting is here, when you compare these numbers, the day gecko and the bearded dragon have the same shape brain.
Interesting.
Yeah. So when you look at the yellow, that tokay gecko, so, the landmark 29, you look up, it's the farthest and the closest one to the edge down. You can see is 29 in the big graph.
Yeah, I see it. Yeah.
So the tokay gecko is 2,000. Every other one is 6,000. Go to the next yellow one, and it's 30. It's right on the other side of the 29. And we see that the top one, the tokay gecko, says 4,000, where the rest are 7 and 8,000. We go to the 31, which is right next to the 29. And we see the tokay gecko has 4,000, where we have 7,000 for the rest. So what this is saying is the tokay gecko's optic tectum, where it dissects sight, is smaller and misshapen from a normal reptile optic tectum.
Mm.
So what does a tokay name is known for?
Biting.
Very bitey, very defensive. So this is why they talk about going low and slow, because it gives it time to dissect. Their sight could be perfect, but their brain isn't dissecting it properly. So when we look at like a brain like this, these are lobes. They have, in the region of the optic tectum, I don't know if they call it lobes or not, but they have sections in there. There's sections. And so whatever section it is smaller. And it could be multiple sections. It doesn't mean it doesn't exist. It's just smaller. And that's why they have a hard time seeing. It's not because it may or may not be from their eyes, but their optic tectum is actually affected in a way that makes it harder for them to make evaluations on their sights faster.
Interesting. Yeah. So that that could go as far as saying the way they interpret a human, for example, could be totally different, right? Going back to Lori's question, how do they see us? Those two species could be completely separate just based off that structure.
What is it? The Ukraine lab, Bion.
Yeah, Bion. I think. Bion. Yeah.
Yeah, they posted a while back that reptiles see us as shadows. They see our outline. They see our hair, the way we move, the way we walk. Totally right. But I was messing with some reticulated pythons at Herp Society. And just like we talked about with the bunnies and the snakes looking at each other and like feeling, I did the slow blink. So predator's going to stare at you. And if they're scared of you, they're going to stare at you. So if they don't stare at you, this is one of the best things to learn. This is why I knew to not look at the bunnies and see their response. And they will let you walk on them way closer than as if you're actually staring at them. Mm. This might be a reason why people are scared of snakes, because they don't blink. Might be one of those inherent things. Yeah. So when we look at this, it's so I was messing with these reticulated pythons. So they're playing over here, and I do the slow blink. It goes immediately right to me. It gets right up on me, it takes a whiff, takes off. I guess I smell to them. I mean, I guess I don't smell well. And so I did it to the other one. It did the same thing. Slow blink comes down like that. So they're seeing that. They're seeing those eye movements. They're taking in that small a detail. And what's really cool at the end of the show, everybody kind of blew me off, oh, Daniel, I'm like, yeah, that's for cats. I'm like, why wouldn't it work for them, for these guys as well, if that's what it means? And so there's a young kid that came by and his mom, and I had one of the reticulated around my neck, and her mom goes, "Can he pet it? Can he hold it?" I'm like, "Yeah, yeah. Do the slow blade." And the kid did. The snake immediately did that. No, it didn't actually try. It was instantaneous, just meaning it was using its optic tactum, and it was just automatically. This is not. I am in exploratory mode. This thing just told me it's not afraid of me. And the mom goes, "I didn't believe that would work." I'm like, exactly. Like, it's really a fascinating thing. So when we get in, like I said, there's so much that the optic tactum does. So most of us here probably know about the third eye in the bearded dragon brain. So that sits right above the forebrain. And I had to get on to Ryan McVeigh. We were talking about this. And I love Ryan McVeigh. He's just absolute treasure. And so it sits right above the forebrain. And he said that they can pick up on actual different colors, like the different wavelengths through the third eye. I said, no, that's impossible. That little dot, your eyes are made to pick up on that. And think of how many layers you have to go through to pick up on those different wavelengths. It goes through the eye, goes to the nerve, then goes to that to get dissected. That's a lot. So you're telling me this little dot picks up the same as all of that? And so for it to actually do that, it would have to travel below the brain, because we know the optic nerve here sits under the brain, which gives them their 260 view. Is that optic nerve sitting underwhere? So this isn't going to happen. That's not how that works at all. That's too little of a signal to travel all the way under the thickest part of the brain to a whole nother spot. So what it does is it actually comes down right above the forebrain and actually travels back right above the brain through nervous system to the optic tactum, directly to it. So it's picking up the shadows and that there is a light and maybe a little bit more, but it's not picking up the different wavelengths. So it's really fascinating, because it is just coming down and traveling that second hump, even though it sits above the first hump.
So it's just able to identify difference between dark and light, essentially, or maybe even the intensity of light.
Yeah, which should indicate movement, right? I mean,
right.
Yeah. So the heat pits on pythons and boas is that labial heat pits. So they have the mustache heat pit, as I like to call it. So think about how much of the space they have. Like, it goes all the way back. And as you look at this ball python, it's so close to the, maybe that's that's a python. It actually goes, it can go automatically to that optic tactum from the very tip of the labials. It's so close, it can send that signal straight to it.
Right.
And no, there isn't any papers on these. I actually, she's brilliant. She's one of the actual best people I've met in the hobby. Like Emily, I explained this to her, and she's like, "That makes so much sense." So but I think that also like puts them off a little bit, since there isn't any papers on this.
Right.
So the L'Oreal pits here is those two dots in front. They are 2 times more faster than a python, and more, like 10 times more accurate, or vice versa. They're accurate to a 0.02, and they're 10 times faster with their heat pits than a python. But yet it's 2 dots in front. What did we talk about signals in, like, the message there? Like, it's that little of signals is not going to travel all that way and be faster than a python. that has a shorter link to get to that signal. So how would this do that? Do you have any ideas?
I don't know. It's like because the
How
proximity
fast?
is. What's that?
How fast does it go from optic tectum to the medulla? Signals go from optic tectum to the medulla. Go fast, don't they?
Right.
Like almost instantaneous. So if these hip pits are attached to their muscle system, of which we do know goes through the medulla, we absolutely know because of that over tactile sensation, we know it does. These are going through the medulla. That's how they're faster. They're going through their muscle system. They've utilized their muscle system to send that signal from the heat pit to the optic tectum to be dissected faster than the ball pythons because they went through the medulla, their muscle system.
Interesting.
Yeah.
So like the study shows, like this particular study shows that these vipers are able to sense infrared energy a lot faster and more effective than the ball python. That's what you're saying?
Yep.
Gotcha.
Oh, yeah. Yep. But what I'm saying is not why? In any study.
Yeah.
It's the only thing that makes sense.
Yeah.
It's it. There's nothing else that actually fits. Yes. But if we were to think about the only other way that this might go is through the venom glands. And it would have to be a massive, and I mean a massive, because like we said about the eye, how much does it take for your eyes to dissect those signals? For this to dissect the signal and to make it faster than the other one, that signal would have to be like that. God, I can't think of it now. The nervous system would have to go through the venom glands, basically, almost, and would have to be massive. Like you would see it. If they're not seeing it, then that's the only other option. There is no other option than to go through the medulla for it to actually be that much faster. It's a really fascinating thing.
Yeah.
And so it shows you how much we've got left to learn.
Definitely.
And so the thalamus, I don't know if, because I've sent you so many things over the years, I always wonder if you get annoyed with me sometimes. Because
I'm always happy to learn.
It. I know, because I'm always learning something. It took me 2 years to figure out one problem that we talked about. We will not be talking about it on this podcast. That is advanced topics. But this is a monitor brain in the bottom. The thalamus needs to be studied so much more. I wonder if Pitch, my bearded dragon, her thalamus and what that does. Because when we go to this bearded dragon brain, there really isn't a lot of thalamus between the optic. Like the thalamus sits underneath the forebrain and optic tectum. Sits underneath it. So those two humps sit above the thalamus. So it actually has to travel down and up. As where it goes back, has to travel down and up. But look at this thalamus on this Aki. It's actually has a signal between. And I hypothesized this before 2023. So I know I've told you. So we could probably go back through Messenger and actually prove that I said this back then. And I know I did. So think about why we think of monitors as so much more intelligent than other reptiles. And I hate that argument. I mean, so the between the forebrain.
Yeah, I think it switched your microphone again.
Yeah, dude. So I moved away from it. No, it's yeah. Yeah, I don't know what it's doing. It's saying it can't read it. It's not reading the
Yeti?
Now it switched it back. Okay.
Yeah, you're back.
So we think of monitors as so much more intelligent because they have more, like this would make sense. that they have more thalamus between the forebrain that makes decision and the optic tectum that has instinctual brain. So there's more communication between those two parts of the brain in a monitor. So wouldn't that lead us to think of them as more intelligent?
Right.
But does a bearded dragon actually need that, since they are way more predator or prey item? Wouldn't you want less interference from your memory, from your imagination, your memory, and your decision making? Wouldn't you want less of that?
Yeah.
So that you can get away from the predator faster?
Right.
Whereas this shows these are more alpha predators, more, because they're thinking more in that faster relief. So I don't like the argument that there's more intelligence, but this shows you why we see them as different.
Yes. Yeah.
But there's so many studies that we need to do that we don't have, that we don't really think about here. Because I'm the only person that's even, remotely thinking about this like this. Like, it's so interesting. And so this is just like left behind. And so, like, Pitch is so smart. I want to see what her thalamus has done. Like, she picks up on things way faster. She's my second smartest reptile, and I have skinks.
Right.
And skinks are super smart, and I've got savanna monitors, and I've got a tag who's my first smartest. But she picks up on things. So information wise, so as we learned, how long does it take to go from memory to imagination kind of thing? Like from instinctual thinking to memory thinking. That's a sign of a possible sign of intelligence. So when I take them to the park, the Tagu got it in one, where he realized, hey, we're going back to the park after one trip. Pitch, at the end of the second trip, started seeing it as her territory. The third trip, so a bearded dragon, this is alert, the tail. This is I'm hunting. So Pitch was like this before we pulled into the parking lot. You couldn't see the park from the stoplight. And she had already had her tail like this before the stoplight. Where it takes all the other reptiles 3 or more times to figure out we're going for a walk. And that's how we might see intelligence. So I do wonder what is going on in her thalamus that might make that decision. Is there something different? We don't know. I don't have an answer. But I find it so fascinating.
Yeah, yeah.
So the OL stock. So we've jumped. And we can see massively different OL stocks. And we know bearded dragons, chameleons, agamas, iguanas often have, like 10 to 15% of their brain is OL stock, whereas skinks and monitors are like over 20%, whereas snakes are often over 30% of their brain mass is the optic tectum or the OL stock. We can see that. And I used to say they stretch the brain, but I think that's a little flawed now that I know what I know. So we're still learning a lot, but I added this T-Rex in here. Imagine what it was like, because he's a vertebrate.
Yeah.
He has all these same parts. So imagine what it was like for him to open his mouth and take a gulp of air. How much of that did his go, man, I smell? Or like, since this is attached straight to your forebrain that holds your memories. This is why when you smell something, like I smell apple pie, so it reminds me of Thanksgiving back in the day when I was a kid.
Yeah.
And it's so good. So these T-Rex are probably eating a Triceratops going, man, this smells and tastes just like mama killed.
Yeah.
Because it is a memory. And it is a legitimate thought that they would have that.
Yeah.
Yeah.
For sure. I mean, that's one thing people, like obviously there are memories that get stored, and how they interpret them or experiencing them is maybe up for grabs, but definitely they're being stored and they can be linked to sensation for sure. If you keep bioactive terrariums, then you know that beneath the leaf litter and the substrate and the soil, your cleanup crew is doing the heavy lifting. Springtails and isopods break down uneaten food, they eat sheds, they recycle the nutrients back up into the soil to keep your system from crashing. And the key to success when it comes to having a healthy, strong bioactive system is having a consistent and reliable source of cleanup crew members. And the BioDude gives you 3 excellent options to achieve this. First are their culturing kits, which allow you to grow your own isopod and springtail colonies at home. These are simple, economical kits that come with everything that you need to establish strong colonies in your own home, whether you are restocking current enclosures that are already running or you're needing to spark and initiate the cleanup crew in a brand new setup. This is a way you can consistently have healthy, strong crew members that are ready to go to work whenever you need them. Second, if you actually enjoy isopods as an animal like many of us do, then you're going to want to check out the BioDude's premium kits. These kits come with a clean, display-ready acrylic enclosure to allow you to display your colonies to anybody that comes into your reptile room. And third, the team over at the BioDude has put together a bunch of species-specific cleanup crew kits. So whether you're getting a bearded dragon, a crested gecko, a hognose snake, a ball python, you can go to their website and pick up a cleanup crew kit that will thrive within the environment of the animal you are keeping. The bottom line is very simple. If you want to have a healthy, strong bioactive system, you need a healthy, strong cleanup crew to help maintain it. For more information on the cleanup crew kits by the BioDude, head to www.thebiodude.com.
Exactly. Which goes back to the fear. So if that fear pops up, it probably is going to bring it up faster.
Yeah.
Like it's very interesting. So the forebrain. So this is where, all of this out here is what we're looking at right now. So we see the bearded dragon and the fire skink, they're different. They're all so different looking. And so when we look at lobes and we start thinking about this, like I said, this is memory, imagination, but they're on different sides. So all of this stuff is happening here. Now, we're not going to go into a lot of the lobe stuff because that's like we talked about before. These are lobes. But I want to draw attention to something before. Remember the frog thing?
Yep.
I left something out of these things. I said I did. I literally pulled out every single name on this thing that was in that paper. And every one of it is similar to a frog, except the cells names. They had cell, and they had these big words that, and when you look up the word, it means small, big, left, right, up, down.
Yeah.
It's like, oh, okay, I can't include that in here because it doesn't mean anything. But what did we just talk about with lobes? So the cellular structure is different. I was listening to Vanderbilt, Introduction to Neuroscience or Learning and Memory. And what they were talking about was lobes and how we found it. We found them going back to the 1800s. And so what lobes actually they found when they cut open, they had different layering.
Okay.
In cellular structure.
Mm.
That's how they found the lobes. So frogs have lobes.
Yeah, I see what you're saying.
I have no idea.
Like the brain itself, the tissue basically from the naked eye looks similar, but then so the question is how can you actually differentiate each piece into a separate lobe? But when you actually look at the cellular structure of each tissue, it's actually different.
Layers.
Yeah, gotcha.
Yeah. So the fact that they are dissecting those brains and going, okay, there's different shapes, different things here like that. They can actually see that under a microscope in frogs.
Gotcha.
Yeah.
That's
reptiles have lobes.
Yeah.
They have lobes. There's so much left to learn here. And we can discuss this at a different one if the audience wants to and they're interested in more understanding of this. I would love to go over this. This is just a beginner course, so we're not really wanting to go into this. So the medulla sits underneath the forebrain. And this is our medulla. And medulla deals with just movement. And as you look at the chart here, spoiler alert, for all studies. Spoiler alert for all studies. When you look at these mandullas, so they have mandullas just like we do, but they sit under the forebrain. I found this because I was trying to figure out their movement stuff. So this middle graph, this is where our body is mapped. And I heard this without seeing this. So I went into depth on this. And so I found movement to be here. So that optic tectum, when it moves your body, it might not just be pulling from the, because this has to be low in the forebrain so that it can pull from it, since this is part of your movement. This is dealing with just movement. Right. So that's why this sits so low in your forebrain, like underneath it, so that the optic tectum is faster grabbing it, so it can move your body faster. But your cerebellum is that, which is a question that we can talk about later, because this is, like I said, beginner. So this is a spoiler alert. Tell me what's the difference between these four mandullas. Which one's the outsider?
I guess the frog.
Exactly. So I think it was Clint that was talking. Somebody was talking about reptiles are actually closer to us evolutionarily than frogs, right, than actual amphibians.
Yeah.
Right?
Yeah.
You guys know more about evolution than I do. So here's the spoiler. The brain is more, closely related to our brain than they are amphibians, it seems like.
Right. And if you're saying there's that many analogous structures between us and a frog, there must even be at least that much between us and reptiles.
Yeah. And it looks like even more that we look at the thalamus, or the basal ganglia. The basal ganglia is what this is.
Okay.
I may have said something else. I apologize if I got that wrong. But
yes, I think you did say medulla, but yeah, you meant the basal ganglia. Okay.
It's the basal ganglia. So yeah, please don't kill me in the comments, or go ahead and kill me in the comments, because, but you get it. Like, all studies are going to find, and that's what we see every time you hear of a new study. Don't they no, these things have feelings, these things have this, these things have that, they like that. This is why. And this was really good showing you this. But here's something. We talked about the human brain and how it's on different sides, memory and imagination and stuff. So this is really interesting. This is trap talk. So this monitor, he's held a lot of times. You see how the head of this monitor, like, he's looking at something, and for some reason, he completely switches eyes. He doesn't have to do that. These guys do it to me all the time. These Chinese water dragons. Yes, girl. She's from Show Me Reptile Shop. She was actually Mickey's one of Mickey's collections. I adopted her. But yeah, so we know, and this is interesting because how we have to teach this is really cool. You've actually helped teach me this, because how many years have I told you this exists?
The eye thing?
Yeah.
Oh, probably 5 years or something like that.
Yeah. But it didn't seem like you took to it till I actually added a story to it.
Mm.
And that's what we need to do. And this isn't a dog on you. Like, this is learning how to teach.
Yes. Yeah.
Yeah. It's like, so Calm Fancy, my big beardy, would sit on top of his enclosure was above my couch. I would throw my phone on my couch. You never, it's so hard because that 260 view to realize what they're actually looking at. But he was looking with his right eye, or his left eye. He doesn't know what my phone is. He's not using his memory. So that means that whatever their version of imagination is, before you go in the comments, well, they don't have imagination. No, they absolutely have imaginations, but we don't know the depth of it. They're not out there looking at the stars going, I wonder if that's a snake. They're probably using it like we use empathy. So the reason for empathy for humans is to understand the events happening around us. Is that not what they would use imagination for? Since empathy is a part of your imagination. So using their imagination to understand the events happening around them. This is why they look with their left eye. Like just, oh. And it's so fascinating because they do. They'll look with their right eye if it's a memory. So they are receiving memory from their left side of their brain. But that's memory retrieval. That's not the whole memory. And that's how it works for us. Once again, we go back to this. This is just like a human. So I'm not anthropomorphizing too much. I've actually seen this. This is not something that is absolutely just out of the blue, which is the point of this guy. He sees something. He's not scared of the owner because he's been held so many times. So there's nothing else going on. He sees something in the room and he doesn't know what it is. So he switches his eyes.
Interesting.
Really cool, right?
Yeah, that is fascinating.
And one of the things that we need to do is, I think, well, we'll get back to this here in just a second. So this that was just weird. Oh, that's why. Yeah, the tongue flicks. See how he's tongue flicking up? He thinks he's about to get food. Remember, this is the forebrain we're talking about, but the OL stalk is straight into that. So as he moves away, you can see that tongue flick furthers down. It favors down, whereas when it goes towards him, it favors up.
I see.
But yet it goes both ways too. And that's where people are going to kind of get confused. Like, this is like no. Up is memory. Down is imagination. This is using both sides of their brain. So we need to change the way we look at creativity. So if you're a painter, you're going to go, this is what I want to paint. This is my imagination kicking in. I want to paint this. So your eyes are going to move to the left. And then you're going to go, okay, so my paintbrush is here and I need to make this stroke. There's a stroke right here. Okay. But how do I make this stroke? Because I want this exact stroke. That's memory. So his eyes should start to dart to the right. So as you do this, your eyes will dart back and forth.
Yes. Yeah.
That's creativity.
Right. Okay.
So,
I mean, that is a well-known thing that when you're accessing memory, people will typically look up, right? They look up to the right. That's that right? Or like
there's more to that. Like there's different lobes that they've correlated with all that. Okay. I don't remember.
But our eyes do really show kind of. It's a common thing for people when they're in thought to look up and to sort of access a different part of their brain. So this is your kind of hypothesis to translate into what we're seeing with snakes and lizards with the tongue.
And we're doing a study on this. I'm doing the study. Okay. So because I've seen this, like I go to shows, but think of the thinking man.
Yeah.
Yeah. So I go to shows and there's a guy with, I can't remember if it was a king snake or a corn snake. I'm not a snake guy. I don't know. I love snakes. I don't have any desire to keep them. The lizards talk to you. They actually talk to me. I've learned their body languages and stuff, and I do have studies in that. So here's the thing. The guy had it, and he was holding it like this, and that tongue would flick up at him, and it just stayed up. As soon as I walk over, that tongue goes down. So I've seen this over and over again. I almost got one recorded where it was actually doing that strongly. And so I've put together a study, and I've sent the draft, the Google Doc to actually do the study to Zach Loafman, to Jonathan Losos, Dr. Losos. He's an evolutionary biologist, and they love it. They're like, no, this is a very interesting study. This looks good. The science looks good here. So we're going to, you should do this. So I'm getting with Dave Levinson because he lives close by, like within 3 hours, and we're going to go to his facility and we're going to put this to the test. And instead of looking at just time, we're going to look at, like, if you actually put a dot right at the top of the head, 45 degrees, 90 degrees, 180 degrees. So once that face is out of that sight, how does it change? Is there a change? What percentage is different for different models? And so we should be able to actually show this. I don't know how the study's going to turn out, but we are doing this study.
Okay, cool.
Yeah. But I've seen this so many times, and the rare people that have actually got to see this with me is very few, but it does happen. Like, it is still. And so once we talked a long time ago, and I'm a scientist. I'm a real scientist. I try to disprove things. I'm not here to prove everything. I want to disprove it. That's why when I talk about hypothesis, it's always, I haven't figured out how to disprove it. Like, there's nothing else that fits. There's nothing else. Instead of, oh, this is just what I believe. No. There's nothing else that fits.
Right.
If it was something else, we should, but then, yeah, because I'm a real scientist. So the forebrain size might correlate with the size of the territory. Makes sense in some memory. So what species has the biggest territory? The leatherback sea turtle. So this is a study in Japan that had these on. And I just had a guy on who is from Alton, Illinois. So he's like 40 minutes northwest or northeast of me. And I didn't realize such a small college would actually be out there doing studies in the middle of Illinois on leatherback sea turtles in the ocean.
That's cool.
Yeah, and he did it since grad school, at least like 20, 30 years ago.
Wow.
So he's really well known in this. So it's really cool. But we see every other version of this. The big head is the leatherback sea turtle. Every other one has the 3 humps. That top one in the row of 3, that is orange head turtle, I believe is what it's called. And that also uses the currents, because the leatherback, all of the mid-ocean is its territory, basically. Possibility for its territory. Because they ride the currents. Well, that too also rides the currents. But if you look at that leatherback brain, it looks like a pile of poo with a dinghy hanging out of it.
Yeah. Yeah, there's not a lot of differentiation happening there. It's sort of just a stick.
Yeah. And that's because it lives in that deep, dark ocean. Now,
Right.
He said that they see in blue. It's the only color that they actually see in. And that's what deep ocean vertebrates, that's what they do. They see in blue because that helps them. But if, this really shows us that this is a blind species. Even though he can see, I still consider it a blind species because of the brain. And so when we look at blind species, look how flat those are.
Yeah, these are true blind species. Like, these are
Yes.
worm snakes and things that are going to have maybe some sensation of light, but nothing much more.
Yes. And so it really shows you how powerful our sight is. Going back to when we talked about blind sight and the cerebral cortex taking up so much power that you actually needed blind sight to see that there was pathways that were in your brain the whole time, but you couldn't see them because of the sight. So this is really fascinating. So yes, they are a blind species, basically. They're not like full blind, but they are, from a neurological standpoint, I would consider them a blind species. And so are these. And it's so fascinating because the way they've got this design, you really have a hard time telling when the OL stalk and the optic tectum begin in the, how they work with the forebrain. But it's so cool. And this, I actually wonder if these guys might have more of ability to have empathy. I don't know. It's a fascinating thing because just because these animals don't normally have empathy the way we do doesn't mean they can't.
Right.
It's just going to be way, 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 way harder to make that connection between the modeling and putting yourself in somebody else's shoes for your imagination. It's just so much harder to make that. So it'd have to go through the thalamus, like really, really deep, where our thalamus is super small comparatively, you know. It's in here somewhere. Yeah, well, they're showing a massive thalamus, but a little differently.
Yeah.
But
Yeah.
like it's spherical, like it's that lightning going out. So that was kind of the talk for the most part. I like to, what is this brain? So audience, what is this brain? This one might be an easy one.
Yeah, and I already cheated because I know what the next slide is.
Yeah, this is a veiled chameleon brain. That was pissy old man. So yeah, so this is a veiled chameleon brain. What brain is this? Uromastic's brain. Yeah, has all the features. It's not the medulla is not like super long. It's not dipping below. So even though they burrow, they're not overstimulated from a tactile sensation. But that's a drawing too. So like this is cool. This is really interesting. So a dwarf chameleon, this Cape dwarf chameleon, and a Jackson chameleon, the brain, those numbers that we saw, when you compare these two, the dwarf might actually have a bigger brain. They're very similar in size. The Jackson chameleon's about 25 centimeters long as an adult. The dwarf chameleon's 15. Why? Why are they the same size brain numerically? I don't know.
Yeah,
I find this
bizarre.
super fascinating. Yeah, like it's so interesting just to take in these things and to have these questions. I have way more questions than I have answers for. But yet this is the basics. Like, and so we can see where now that we've seen all of this, when we go back and we really look at this, we can kind of understand why this makes sense so well and actually see how these things move together. This is probably one of the most important things. So the medulla sends information to the optic tectum. The optic tectum sends information to the medulla because they are basically one and the same because they're attached straight together. There's nothing in between.
Right.
So it's really fascinating to think how you learn from this. What is your thoughts?
Well, I think it's fascinating. I think you're definitely thinking out of the box. You know, like there's so many things here where I think intuitively it makes sense, but a lot of times people are kind of worried to make hypothesis about these things because reptiles are conventionally animals that don't think and don't have memory and don't have emotion or can't feel empathy. And, I think that there's some really solid hypotheses that you've made. And even just the fact that there are some studies out there to correlate some of the things that you're saying, whether it's the brain size increasing based off of the type of movement that animal does or the type of tactile feel that they're a response to. What it really shows is the environment is carving the brain out in a way. I think that leatherback sea turtle was a really interesting one because you have an animal that lives in a essentially dark water, and Mother Nature's amazing at just carving out the things that aren't necessary. And, you've showed that really well.
And their brains don't get much bigger than your pinky.
Yeah, thumbnail. That's fascinating.
Like it's so interesting when you look at it like that, because it's, so many people, this is this and this, and they don't think, they don't get bored, they don't do this, and they don't have thoughts, they don't have emotions. It's like there's so many circumstantial evidence to support that they do on all of that.
Yeah,
that it's ridiculous. And I would love for people to go out there and actually prove those hypotheses that they have, because they don't hold up when you start trying to disprove those hypotheses. How do you prove that they don't think? How do you prove that they don't feel? How do you prove that? Because the bearded dragon, Blackbeard, automatically proves that. And here's the thing. And people go, yeah, but my snake. Hold on a second. If there's one reptile that has it, it's feasible for every other reptile to have it. They may not. So when Mick Mutton says, hey, they don't get bored because a snake crawled into a wall and was there for 6 months. That Pitch gets bored. Pitch, the bearded dragon, gets bored. What does it mean when they get dark right here under their chin? Under their ears?
Like the jowls, yeah.
It means I'm a little sickly, I'm a little upset, or I'm a little annoyed. Right. She keeps this chin strap. So we've been going to Dupree Park for a long time with the Tagoo and the Beardies and stuff. And it's really fascinating because she likes to sleep. She finds humans incredibly boring. When I go do Read to the Reptiles, I belong with the Herp Society of St. Louis, and we do Read to the Reptiles and stuff. August for Earth Day or Conservation Day, we will be at the Magic House here in St. Louis. So if you're near St. Louis, come by that Earth Day, look it up on the Magic House, bring your kids, you'll get to meet us. There's more shows. The Magic House is a science center here. And then go to the St. Louis Zoo for free, and you get to see a Komodo dragon. And they have one of the biggest, snakes for venomous. So you make a whole day of this still for, the kids and stuff. I love it. We spend they leave after 4 hours. I'm there for 6.
Yeah, so, that's awesome.
So what were we getting at? So Pitch gets that chin strap. And when we do Read to the Reptiles, Calm Fancy will actually turn around and watch the kids as they read to him. He actually likes people. She's indifferent, completely indifferent to you. I have 12 people standing around her trying to poke her. She's staring at the fish at Bass Pro, going, puffing up. And the puffing up is, I'm too big to eat.
Yeah.
And so she's focused on it. No care about humans. Every time I hear somebody go, oh, well, she's looking at it, it's like, no, she's looking beyond you. No, she doesn't care. That's Pitch for you. It rhymes with B, it rhymes with Pitch, but starts with a B. That's her full name. She responds to that. So we go to the park, the pre-park, and she sleeps a lot in the stroller and has the full deal. So we go to a different park for a while. I took her to Bass Pro also, and she turns around on the stroller and tries to jump off, while all the other reptiles are focused on the fish, and the fish are double taking the reptiles. So she turns around, jumps off, and then so she's bored. There's no doubt about it. So I take her to a different park that we haven't been to in quite a few months. No chin strap. She's black right here. No chin strap. I take her to Bass Pro. She focuses on the fish. I reinvigorated her by taking her to a new park. So they absolutely 100% can get bored. Does it mean that yours get bored? I don't. But one gets bored, they all can get bored. The feasibility of that is true. Yes. There's no doubt. You can't just go, oh, well, no, you can't even prove that snake wasn't bored. And then there's more questions. And I wish that they would do that more. People would act that way. So instead of Nick Mutton saying, hey, this thing doesn't get bored, it's like, does it get bored? Instead of, is it bored? Why would it not be bored? Well, all these different questions. And I can answer some of those. But that's something I think we should leave for another episode. Yes, if the audience wants that.
Yeah.
But it's really cool. So my background, I have an associate's in physics, a bachelor's in polymer chemistry. I grew up out in the backwoods. I have studies in nonverbal human communication. I grew up in the Blue Hills of Missouri. It's just Arkansas border. You walk into the woods, you're that. I grew up a town away. I didn't have somebody that was my age that lived a mile near me till I was in junior high. So I grew up alone with a 5-year-old brother who was learning disabled. I probably should have been a special child, not special ed, but all special kids, the ones that advance, that's what should have happened to me. But I was kicked into the special ed program.
Mm.
Where I have a degree in physics. Nobody ever looked at me and said, you can do math really, really well. You should go to college for math. So I grew up not having that belief systems and stuff, like the education wasn't, but I went to museums and all sorts of stuff. So I went back to school at 26 and I got a degree in physics while working at Lazy Boy building chairs at night. So awesome. it was a lot. And so I got my first Reptile. So I wanted to study neuroscience, chaos theory, and quantum mechanics were my three things. I didn't actually read a book till I was 26, like a full novel. I read graphic novels, and that was The Black Hole Wars by Leonard Susskind, My Battle with Stephen Hawking to Make the Universe Safe for Quantum Mechanics. So for people in the audience, so the anything that you think I'm wrong on, you might take a tone back and go, okay, or things that I should have added that you think I should have added. Take a step back, breathe, and go, hey, would this have been better as a teaching method? And so we often think of Stephen Hawking. I know I'm kind of bouncing all over the place.
No, go for it.
But we think of Stephen Hawking as really smart, right? Really, really smart. Yeah. He wrote all those books. People read those books and went into those fields. And they proved him wrong. Those people that went into fields. So I'm actually in the process. And the only reason why I have stopped is I have Savannah monitors and I have babies. I have two clutches that I got to deal with. But this is an outline to a book that I'm writing. And so we have the basic understanding of the cerebellum. All chapters are like this. So we'll go over the basics so that the average person can understand it, kind of like what we did for this talk. And then more detailed structures, regions, and cellulars of those parts. And then when we talk about the experiments that I think should be done and actually how to set those up. I'm a real scientist. I know how to set up experiments. And then theories, things that are hypotheses that we need to look into and stuff like that. In that book. And so because there's so much we don't know, that's why I want to do the hypotheses and stuff. And I would love to come back on and work that in to this talk to where we could actually go over the theories, the hypotheses, the things that I understand on these topics that we still have more questions about, as well as a deeper understanding of the parts of the brain. Because right now what we want to do is we want to focus on allowing that, just the basic people to understand it. Yeah. So if I got things wrong and you were able to prove, so my goal for this whole talk, I actually had this, I thought of this. You wanted to know, how does somebody find themselves how does one get into, I know I'm rambling. I'm so sorry, guys. How does one get into the neuroscience of reptiles? Under normal conditions, under a normal person, you don't. You just don't.
Yeah.
But this is why I have this talk. This is why I have to do this talk. I've given it multiple times now. To me, prove me wrong. I will sit there and I will clap for you the whole time. If you're actually, because my goal is to advance our understanding of the animals.
Yeah.
So if we actually understand the advancement of the animals, because you proved me wrong.
Thumbs up.
I am all for it. I will sit there at your Nobel Prize speech for you.
yeah.
Clapping. I love it. I didn't fail. Even if my name is forgotten from history, I didn't fail if that occurs, because that was my goal. And so it's so fascinating. And I think that's something that I think a lot of people should take away. Like, it's so easy for probably people to make fun of me. I don't give a shit. I apologize. I'm trying not to cuss on this one, but
no, it's totally fine.
I had a veterinarian who laughed at me at the talk. She didn't like me from the beginning, though. I could tell before that. But everybody else, all the regular people, all the zookeepers, they actually came to me like, dude, we loved your talk. We loved it. So I really do. And I hope somebody like goes into this because of this or whatnot. But it's so fascinating too, because there are things that I left out that somebody might go, hey, like this. But, you know, teaching is so hard to figure out how to teach this. Did you actually think for the longest time I could teach this? Like, it was probably very questionable, wasn't it?
Well, yeah, exactly. I mean, you had to develop the ability to convey the message, right?
Did I convey it well?
Yes, I think you did. Yeah, I think the presentation's good. I think, like you said, I think you'll probably spark at least conversation, and I think people will go. I think what people need to remember is a lot of this is hypothesis. Like, you're able to look at the data and kind of draw your conclusions that you can back up, and it's not necessarily that you have it proved in a lab somewhere to say this is. But this is the beginning point, and like you said, if this sparks somebody to take a study or to help promote a study, then that's what we want to do.
I recently found out Isaac Newton was super petty. And that's how we actually have a lot of the equations, because he wanted to stick it to other people. So if you want to stick it to me and prove me wrong, you go ahead and you do it.
Yeah.
But just know I'm going to cheer you on from the back seat.
Yeah.
And that's the reason why I can do this. Like, I always say you can break everybody down to one question. What makes them feel self-important? So, most people don't have an answer to that. And the worst answer I've ever heard was from Mariah. Yeah, like it was so bad. I was like, oh wow. I had to stop myself for just a second and just gloss over it like you're supposed to when you're talking to people, like when they make a mistake. It's like, yeah. She said, I am important because I'm right. I'm like, that's bad. Like, that's really, really bad. The key to happiness is sustainable self-importance. So I am constantly learning. I am constantly learning how to teach. I teach. Those are all things that you can do sustainably. I'll never run out of something to study. I'll never run out of something to teach. Even though it gets so boring sometimes when you recite the same thing over and over and over and over and over again. I'd rather go do the study, but yet you don't always get that option. Sometimes you got to present. And so it's really fascinating. So when we look at Mariah, and she would agree with me on this one now too, because I did. How many things does she have to figure out to make those guides?
Yeah, they're huge.
Yeah, so she's always constantly having to learn, just like I do. And then she learned how to teach it, just like I had to learn how to teach this. There's a lot of self-importance in that. Doing the sword stuff that she does. She likes talking about that and how her students do that. That's self-importance right there. Learning that you've learned to teach, and that teaching is actually self-important and sustainable.
Mm-hmm.
So that's really what her self-importance is. She just didn't have a good answer right away.
Yes, yeah.
And those people out there that do that, I have to be right. Phil Leaps is going to hate me for this because I'm kind of attacking some people, because I know there's some people that she hangs out with that are, I have to be right. I have to be right. That's my self-importance. I have to be right. It's like, that's not sustainable. There's no sustainability in that. And so it's really fascinating. So, always keep that in mind, people. Like those people that are going to be like that are going to treat you like that. Their self-esteem, they have self-esteem issues. They have issues. It creates bad professors, those people like that. Zach Loafman and Dr. Losses, they both were like, dude, this is great. Like, they weren't like, oh, well, this is terrible because you don't have a degree in a PhD in biology, and you don't have all this stuff. So this is terrible. It's like, no, they were just like, this is cool science. We want to know more. Their whole self-esteem is not being the smartest in the room.
Mm-hmm.
It's not sustainable. So, just always remember that. So the people that judge you, that make those deals, there's nothing you can do about those people. You can't control others. They're going to say what they're going to say.
Yeah.
Once you stop, you can open up so many doors to your own belief, your own thoughts, and you're proving things out. but I always also like, how many times have I wrote you about stuff? Like, hey, dude,
Tons.
because you looked at that Google Translate. Yeah.
Yes. Yeah. Yeah.
Yeah.
Yeah.
Like I overdo it, and I'm so sorry about that. But I get so excited. You can tell too. I know
Yeah.
you
Yeah.
can tell because it's like, oh, dude, I looked at this, but it doesn't make sense. But what about if we use this? Like, oh, dude, what about this? Yeah,
Yes. Yeah. Yeah. Yeah.
like 5 minutes later, like, oh shit, many mundane tasks that my brain's acting in the background. And I think most people can understand that when you're sweeping a floor and something pops and stuff.
Yeah. Yeah. Your
So I
mind's
mean,
just
there's so
following
many
rabbit
more
holes.
things for us to take in.
Yeah. Yeah.
Yeah, and that's great. Learning to control those rabbit holes too. But I know what the difference is between a delusion and an actual like thought, like actual memories and stuff. So, I don't fall under that category. Like a lot of people do. And I grew up so differently. Like this is this. So I studied before I even went to college, the neuroscience of autism and the neuroscience of empathy, like we talked about, and the neuroscience of blind sight. I'm not really as autistic as it might come across. I do believe I have dyslexia. And it's genetic. My father also does crazy things that people can't explain and understand, just like I do. And what happens in autism is there's a piece of their brain, often in the forebrain, but not always. That's why autism is so wide, like it's so varied.
Yeah.
By the age of 2, something has overgrown, has overdeveloped. So now imagine making a connection between that part of your brain. It's why, they might have a problem with empathy, but then they spend more time with an animal. They have more empathy for that animal because that allows their brain to make that connection because it takes more time to make that connection. It's not that they can't. It's like being an adult for that one little part. And so all of a sudden they have nothing connecting through it. And so now there's something that's going through it and it takes a lot longer and they're more likely to spend time with reptiles than that. Oh, there was something else. But so for me being less likely to be autistic and more likely to be because I can write the same dates over and over again. And all of a sudden, like all the math, everything on the paper works right. You go back to all my paperwork at work, it's a date that I mess up. And I wrote the same date like 5 or 6 times before that. All of a sudden, so it is a version of dyslexia.
Right.
Because it's the same thing as autism, except there's no overgrowth. It's just different connecting parts of your brain.
Interesting.
And I find that fascinating. Something else we could talk about sometime. That's really cool. I think the audience, because how many times have I started to hear people talk about mental disorders and stuff in the hobby?
Yes. Yeah. Yeah.
And how that's for. So I almost dated this girl that's in the hobby, and it turned out that she's what's called a dismissive avoidant.
Mm.
You grow up and you don't have like you're emotionally neglected. You don't, and you also don't have a guide for positive relationships. So if you're a positive relationship, they have to run away because it's terrifying. Right. I don't know what this is. I gotta run away. And that's what that is. And that's what she ended up being. Like I figured that out. And she'll tell you all day long she's not, but she absolutely is. We got deep into it. And but it made me wonder how many avoidants are in the hobby. So I always tell people when it comes to dogs versus reptiles, it's my grandparents. My grandmother was a saint. She loved you no matter what you did wrong. Like just a saint. That's what most people think of as dogs. It's not always the case, but it's what most people think of when they think of dogs. Unconditional love. Well, reptiles are like my grandfather. If you got an I love you, you earn that. That was never freely given.
That's a great analogy.
So think about, yeah, it really is. And to think about it that way, reptiles don't just give you trust. My Savannah monitors, the adults still hate me, but they run into my room when they get scared.
Mm.
Yeah, so they trust me. Like there's some trust. I earn that. That was not freely given.
Yeah, they did not come out of the egg like that.
No, they do now because I have baby Savannahs, and I've got a few I've got some I need to sell. I've got one that is just awesome. It I think it's a girl. I know that the feisty one that's about 4 months old right now. She is like, she's a girl. The other one I think is a girl, but oh my God, she literally comes to me like begging, like, oh, like a dog. Like, it's just like, oh my God, it's so awesome. Another thing, so they asked you how to hold a lizard in the lizard lounge.
Yeah.
This is important stuff because I teach kids this. I've been teaching this for years. I could pull up pictures where at Read to the Reptiles, I teach kids to do this. Clint's Reptiles finally did it last year, like talked about it, had that study with the snapping turtles. You support all the limbs. So it's, I know, buddy. Come on. Captive bred zebra skinks. So you see how I'm not even holding it, but I'm supporting all the limbs.
Yeah.
And so this is one thing that, like, Bo, I don't see a lot of people actually explaining this well. Even in your lizard lounge, people were asking in the comments to show it. So support all the limbs. You always support the limbs. You don't. But if it's something that's scary, you hold it like this. Like, you hold it from the sides, lift it up over your head. You're not looking at it, but then hold it out so you can see it with your peripheral vision, but you're not staring at it. I am in the process of possibly having a goat wildlife on, and or not on, but having him over to the house just so you poop on me, buddy. Okay, buddy. All right, we got you. They're captive bred right here in St. Louis, but I've got a couple of species that are unholdable for most people, and we're going to let goat hold them. We're going to teach him how to hold them properly. And I've got video of a giant golden land mullet skink, second biggest skink in Indonesia, and it is bitey. Like it like that. Hold it. So when you're doing this, we go to the optic tectum because it's almost instantly calming down. They will instantly calm if you show them a reptile that is calm, or a window. Showing them a window, going to it. And I've got video of this. So this isn't just like, oh, this is just my, no. Like, that's how you calm a reptile down. Hold it over your head. If it's not calming down, you hold it out. You don't stare at them. But you can still see it with your peripheral vision, and you show them a window. Now, as time goes on and that forebrain activates, they get wiry. And if you're holding them like this and they're still wiry and you're not looking at them, because what you're doing is not setting off that fight or flight. And so if they're still active, still like fighting you, it's because they don't know. They're unsure what's going on. You're not really setting off their fight or flight. They're just unsure. So when you show them a reptile, it instantly calms them down.
Right. Interesting. Yeah. That's very fascinating.
So yeah. So let us know if you guys want. Let us know if you guys want a second episode, what you guys want to talk about, anything that you think that I might have gotten wrong, right, whatever you want. Understand that I would love to hear from you guys. Dylan, you're open to doing a second episode, even though I'm the crazy guy in the hobby?
I think this is a good launch pad for reptile neurology talk, just neuroscience in general. And like you said, if the commenters are interested in more, like I know that you have way more to talk about, and this was a good foundational episode, I think. And we could do a lot more. We could have other people on as well, do like a round table type thing. We've talked about that in the past, to have other perspectives. And I think this is. And if people want more information from you, like maybe you could let them know. Remind them of the channel name and maybe some of the type of videos that are on the channel.
Learning for My Reptiles. I don't know if you watched it. I got feedback from it. I just produced a video. It's 50 minutes long about how reptiles see us. And I used a video game, the Cyclonauts, to show that. I know that you know Responsible Reptiles.
Yep.
Up in Canada. Yeah. Great guys. I've been talking to them for years once they were on Daffy. And because I had some mountain horns for a little bit. They're wonderful people. I absolutely adore them. But he got back to me. He was the only person to get back to me on it. He said, I have to watch it with more intent. That's probably what will happen to this is I have to watch it with more intent. And I was like, is there a problem? He goes, no, no, no. You're just so informative that I have to watch with that going in mind. And yes, I still have poop running down my arm. Yes.
That's part of being a reptile keeper.
Yeah. It really is. It really is. But yeah, I love you guys. Anybody that has stayed this, I want you guys to understand that how much I appreciate this. And not just that, but the fact that you probably there's somebody in this audience who thought they couldn't learn any of this. Mm-hmm. Like, this is too complicated. I can't learn this. Did you take anything away from that talk? If you did, then you did learn. You did it. You did what you didn't think you could do. Phil Leafs is going to love that. But you did it. And I am very proud of these people. Like, I love that. And there's going to be somebody in the comments, oh, yeah. But then there's going to be somebody going, dude, I learned so much. Like, that really was really like, oh my God, eye-opening.
Yeah.
And that, I love you all for that. I absolutely thank you much, guys. And hopefully I can get a book out within my lifetime.
Yeah.
I did find an artist to do the stuff too. So
fantastic
on that. He, I work with I wanted to make sure that he got paid. And since I can't really afford that work that he's going to do, I asked him if he would take a commission, 20% of the book. But then last time I met him, I told him, I said, dude, you should make a concept book as well. Sell that concept book. It's 100% yours. We will double it with that. Another thing that I would like to do with this book, dude, he really got me with the poop. He really got me. And so another thing that I would like to do is, because we're going into the cellular structure and things like that, and actually using academia papers and things like that, I would love if this book actually became a classroom. How much residual could I get from actually making this into a class book?
Like a course.
Like, that's the whole purpose. Yeah, like an actual course. I would love to teach it, but I know academia at my age, I mean, I'll be lucky if I actually make it alive long enough to write the book. Mm-hmm. Like, it's a lot.
Yeah.
And I'm an old man. And I had people tell me, well, you spend 10, I told the lady, I said, there's some studies, and that veterinarian goes, oh, we got to take 10 years. I don't have 10 years. I don't have 10 years to work on this stuff myself. So I do need other people to help. And so this is, one of those call outs to other people too. But yeah, I mean, needs to be advanced. The academia is so focused on the narrow views and on the actual size. And I can show you every day, like we were talking about the medulla and how it was showed us. There is so much left to learn that's not just about size. Mm-hmm. And if you actually watch that video, the inside, I go over some things about the forebrain and how they see themselves on top of it, on top of how they see us. Yeah.
Very cool.
So fascinating. And it is like, it's a hypothesis, but it makes perfect sense. Like, once you do it, it's like, yeah, like that. I don't see why that wouldn't be correct. Like, and so, yeah, I mean, I would love for this to go forward, and I know you need to go, and I appreciate you guys. I love and respect every one of you guys to a point. I shouldn't say that. I know too many people I really am not a fan of. Yeah. Phil always has to get on to me about, my ego, like sounding egotistical, even though I'm not really egotistical. I just don't care enough. I legitimately, like, you guys care, like, oh, well, I can't talk about this, the job. I'm like, dude, I want to be me. I don't know any other way.
Yeah.
I don't. Like, I talk about it at work, and I'm going to be honest with you. The people that actually do care about it at work are something amazing. Like, they are amazing people. And usually those people are like I've met so many incompetent people. Those people are competent on top of that. And I'm gonna tell you, meeting people that are competent is so awesome. So if you're competent and you're in the audience, I want to be a part of your life. You want to be a part of this. I want you to be a part of this.
Awesome. Well, Daniel, that was
guys.
Fantastic. Thank you so much for dropping all this knowledge on us, and looking forward to seeing how this develops, and people in the comments can let us know where they want things to go from here. You let everybody know your YouTube channel, and so this was an absolute pleasure.
Learning for My Reptiles.
Learning from My Reptiles.
Yeah, and hopefully the editing isn't so bad for
Liam.
I know his name.
Liam.
Not on top of my
Liam.
Yeah, Liam. I've talked to him before. Great guy. I love that guy. That guy's awesome. But yeah, hopefully this wasn't so bad for you, Liam.
Oh, he'll be okay.
The editing part.
Awesome. Thank you very much, Daniel.
Thanks.
All right, that is the end of that episode. Daniel, thank you so much for dropping by and sharing all of that information with us. It really is a lot. And like I said, it's a great foundational episode for folks. So if you enjoyed it, to listeners, let us know in the comments. Let us know what you think. Are there some areas that you think Daniel is missing? Are there some areas that you think you can add? Please let us know. We can continue this conversation into the future. And I think that is it for this episode. If you enjoyed it, make sure you share it on social media or leave us a comment. You can also find more information about the podcast on animalsathomenetwork.com, or you can support the show by going to patreon.com/animalsathome. I will catch you guys in the next episode.